Hello everybody, I hope you can all see me and hear me. My name's Jeremy Cockcroft. I'm a member of the CIBSE Scotland committee. This webinar we're going to hold this afternoon, it's going to be delivered by Chris Clark. Chris Clark is the Managing Director of Emtec Energy. It's an energy and renewable technology provider. And he's going to talk about the deployment of solar in Scotland. I guess some of you might say, what? Solar in Scotland? Really? Yes, indeed. And Chris is going to reveal all and show that it's a real opportunity for engineers in Scotland to grow their business. So without further ado, I'll pass you over to Chris. And
thanks, Jeremy. Thank you. Afternoon, everyone. So yes, as Jeremy said, actually, and I think during the presentation, hopefully you'll get an idea that it's not really Scotland that doesn't have good weather, it's just the west coast. So the east coast, the radiance levels are fantastic, and some parts of the west right on the coast as well. So you'll see that actually the radiance levels in many parts of England are similar to Scotland. So there's a huge opportunity still, which hopefully I'll get a chance to explain. So I'm just going to share my screen just now. Okay. So yes, thank you everyone, and thanks Jeremy and the CIBSE organisation for inviting me along. We had an opportunity to speak in live to actual human beings in person in a room a couple of years ago, and hopefully that had went quite well and was quite informative. And I see a couple of the names popping up in the participant list that I recognise anyway, so couldn't have been that bad. So thanks for having me on again. So I'll just do it very quickly for anyone that doesn't know. Emtec Energy is part of the Emtec Group. We're a kind of large M&E contracting organisation, which many of you will probably be away for. Been going for around 18 years now, have a turnover around 80 million, around 650 employees. I look after the renewable side of the business, so my background actually is consultant engineering from university, where I was there for a few years, and obviously I know probably quite a few of you within the organisation. So that's 10 years now that I've been here at Emtec as employee number 1 in Emtec Energy. We had our 10, ironically enough, we're just coinciding this with this webinar today, but we had our 10-year anniversary on Sunday. So probably in terms of, we've done thousands and thousands of installations from small kind of scale domestic type to now we're out developing megawatt solar farm type installations, albeit haven't yet delivered them in Scotland. Hopefully by some of the numbers I'm going to show you in terms of deployment, you'll see that that's been taking a wee bit of time up here, and there's possibly some reasons for that. So I suppose I should be fairly well versed in the industry. I used to chair the Solar Trade Association in Scotland for a number of years as well, which is now called Solar Energy Scotland. So I chaired that, and I'm an active member in lobbying for deployment of more solar and more battery in the industry and trying to remove barriers. So hopefully there's a wee bit of insight there. So that's just some of our Emtec kind of presence across the UK. The type of tech we don't just do solar PV, albeit it is certainly, I would say, around 80% of the business that we do. Battery storage, we're delivering several frameworks just now, and you guys maybe get involved in a lot more of that, and certainly you will in the future if you have not already. It's still, I mean, certainly solar's still in its infancy in the renewables industry, but once battery tech moves forward a wee bit, we get a wee bit more deployment. The cost versus payback works out a wee bit better also, then hopefully things should move forward in that industry as well. So we can see batteries been a huge part of it. Clearly EVs and heat pumps, the synergy between all that tech will be there as well. So we cover all those technologies. So I felt it important to probably kick off with what are Scotland's ambitions when it comes to net zero and decarbonisation. So the UK are looking to become net zero by 2050. Scotland, as you would expect, would want to beat that. So their ambition would be by 2045. We have declared a climate emergency. You'll probably hear that word quite a lot, particularly with COP26 happening in a few weeks also. And I did hear some rhetoric from Greta recently about the blah, blah, blah culture, which you could take from what you will, whether declaring a climate emergency means that we're actually acting quicker or not. But we have as a country declared that, as many local authorities across the UK. We're doing several frameworks for local authorities in the north and northeast England, which have also locally declared a climate emergency. So there certainly is a lot of appetite to move quicker than what the original targets set. So as part of this climate emergency and of our net zero ambitions, we are looking to decarbonise 1 million homes and 50,000 non-domestic buildings by 2030. So that being that the biggest issue towards net zero is heat, really. I mean, solar will play a big part of that. Obviously, wind has had a massive impact already, but you will certainly see in the type of buildings that you will be involved in, the decarbonisation of heat being massive. Now, many of you may be aware that there's consultations out just now for the new building regulations. I'm going to talk a wee bit about that later and what that potentially means for the industry and certainly the solar industry. Scottish Government are currently revising their energy strategy for 2021. So the last one, I think, which is that Scottish Energy Strategy, Future of Energy in Scotland image that you see there, I think that was maybe 2019, 18, I'm off the top of my head, I can't remember. But so they're revising that and they're going to go into much more detail. And we expect, and certainly as a solar industry, we hope that there's targets in place just now. If we have targets in place, it lets everybody else set up for this change that would happen. If it's just a case of we want to decarbonise and reach net zero by 2045, industry doesn't really get a chance then to properly kind of grab it and have something to focus towards. So certainly there's a wind target, offshore wind target, there's a EV target and there's a heat target, but there's other parts of the industry there's nothing much mentioned just now, so we hope that to be included within 2021. We're looking at reducing emissions by 75% by 2030. I think that's by 1990 levels. And one of the biggest things about these documents is this whole system approach. Now, that's not just in relation to electricity, that's to do with gas, that will be to do with hydrogen, that is to do with everything. How do we look at decarbonising transport, everything? We've seen a big impact on the decarbonisation of transport soon, and you will see, you know, a lot of behaviours will change. I think that as engineers such as yourself, that will be one of the hardest things to determine, because the building that you build and how it is used and operate today, or that you design, the behaviour within that building will change quite dramatically over certainly towards 2030. So it's trying to look at that and future-proof and make sure as engineers, I think, that we're giving the clients the best system that they can have and that they can adapt moving forward. And again, one of the key things, and you would expect us, I know as engineers you would be looking at, you know, there's a lot of, we're going to be looking at heat networks, so there'll probably be a lot of services that you'll now be required to be involved in terms of district heating, social housing, domestic properties, all that kind of thing, which perhaps historically you wouldn't have been. So this whole just transition, how do we make sure that no one is left behind as we move towards net zero? And the fuel power is a big part of that. I'll probably talk a wee bit about it later, but certainly the cost of electricity, as you'll have seen recently, has went through the roof. Ofgem have just lifted the price cap, which I think just happened the 1st of October, or certainly in the last couple of days. So I've certainly seen a massive impact and a massive impact to the clients that we're dealing with in relation to paybacks. So we might have had paybacks of 5-6 years, which will be down to 3.5-4 years now for solar installations. So, and that is only going to rise. So these are things that perhaps traditionally as engineers we wouldn't think of it that way. We wouldn't look at what is the TOTEX cost to client, what is the life cycle cost to the client of this building. It's always, the construction industry has always been about More so it's been about the capex. What can I install just now? How can I comply with building regulations? What is the bare minimum I can get away with for the most cost-effective build for the client, rather than that long-term view? So hopefully I can explain a wee bit about that, and certainly my view of it. So one of the most, after the Scotland's energy policy document that was introduced, again, this is a moving target all the time. So the Committee of Climate Change, the CCEC report, 6th edition, was issued in December 2020, and it's a 400-page document or what have you, so there's some nighttime reading if anybody would really like to read it. I'm sure most of you probably already have, but one of the parts of it that I find the most interesting is in one of the appendices, they have broken down different technologies and where they believe under different pathways that's what's required for net zero in 2050. So I'm obviously here to talk about solar today. So if we look at solar, and if we pick the balanced pathway, which is probably the most likely, I would think, in my view just now, you're looking at 85 gigawatts of solar in the UK by 2050. You could argue 2045 if that's Scotland's target, but to reach net zero. Now, today, in the UK, I think I checked it back to the beginning of 2021, and we had delivered 14 gigawatts of solar. So that's quite a substantial change, and that was during quite a time of subsidy, etc. There was a real big retrofit domestic deployment levels hit back in 2012, 13, 14, when the feed-in tariff was obviously at its kind of highest level. With all that going now, one of the biggest opportunities that I see is certainly in the non-domestic construction industry, both retrofit and new build. I don't know how many solar projects many of you have been involved in, but I would think something substantial in terms of solar, probably not that many or not that big. If any of you dialed in last time, and obviously the kind of summary of what I was going to talk about is the kind of tick in a box. What do we need it to get past building regulation? What does the energy model say? What is the minimum I can get away with? And I'm going to show you a couple of examples of that today as well. So if we have to achieve 85 gig, we are currently at 4 gig. So we are, 14 gig. So we are substantially away from where we need to be. And it's interesting if you look to the right-hand side as well, when you see the column of the levelized cost by 2050. I think that solar and wind will probably be a wee bit less than that. I think if you look at nuclear, I think it'll probably be a bit higher than that. I think if they're looking at things like Hinkley Point, their strike prices agreed of in excess of where it would be just now of £100 a megawatt. And right now, on a CFD pot, which is like the government kind of guaranteed price you would get for you to build a solar asset, you would be at mid-40s just now, pounds. So you would be much less than half the price of nuclear. So it has shown that it is certainly, in terms of larger scale stuff, financially probably one of the best ways to go, along with wind. And I believe that this energy transition is not just, there is not one solution. You know, when we said previously a whole system approach, even if we just look at whole system from an electricity perspective, everything needs to fit. Everything, including if we can get carbon capture there, nuclear, biomass, if we can make it sustainable, certainly solar and certainly wind, both offshore and onshore. So one of the biggest opportunities that I believe we have just now is co-location of wind and solar. One of the biggest barriers would be grid. So we already have grid in place for a lot of these wind farms, and a utilisation factor of a wind turbine would be something like 0.3. So that grid connection, you can, if you add solar into that for the same grid connection, because it's usually not sunny and windy at the same time, you can get that up to 0.5. If you can then add battery storage up, you can get that up to 0.7. So you can then, use the infrastructure that's already been built to combine all these assets to make sure that this net zero electricity network is actually net zero. And again, we talk a lot about we have produced 70% of our consumption, perhaps, but because it doesn't happen all at the one time, that statement itself is a wee bit misleading. Because yes, when it's really windy or really sunny, yes, then we export down. But what happens when it doesn't? I look today. I'll show you a wee bit later. But there was coal active on the electricity network today. So it's understanding that and understanding the political rhetoric compared to what the industry actually sees. So where are we at in terms of deployment levels just now? Last, I could probably say, which I think, considering there's a climate emergency, one would say that you would probably be quite surprised by that. But then, as Jeremy said earlier, we're talking about solar in Scotland, and it's almost like a wee kind of joke that you know, the sun never shines in Scotland. But in actual fact, when you look at it, the radiance levels are actually pretty good. And as I said earlier, we have a really good infrastructure in place already, and a huge appetite to decarbonise. So there's a huge opportunity. If we look at Wales, have done a fantastic job so far. I don't see why Scotland should be falling far. There's certainly their decarbonisation ambitions are match ours, but and you would argue possibly that their geographical landscape would be fairly similar in a lot of places, but we are far behind where Wales are. We are far behind where the UK are, and again, you would think that Scotland would be more ambitious than the rest of the UK when it comes to what we're trying to achieve. And if you look at Denmark sits roughly about the same longitude as what Scotland does. But yet again, yes, when I look at electricity consumption, we're at probably a quarter of them. Per head, we're again at probably a quarter of them. Per land area, we're probably at a third. And GDP, we're probably just over half. So I think that shows, hopefully, that I think that's quite powerful and shows that we have a long way to go, and certainly in terms of solar deployment. And again, as I said earlier, the synergy between all the technologies as we move towards net zero is going to be really important. So there's a huge opportunity with this. When you look at these graphs, I feel disappointment, but I look at the opportunity. So I suppose now, you know, it's important for, as I've been involved in the industry for quite a while, you understand why is this? Why are these numbers so low? So let's look at deployment levels, or sorry, the barriers to deployment. So as I said, and we said their perception, it's never sunny in Scotland. Actually, if you look at this irradiant map, you'll see that you know, along the coast, as far up as I suppose as you get to Elgin, and as far up as the middle of the Outer Hebrides, you can see the irradiance levels are the same of Middle England. So there is a big opportunity there. Yes, there is certain places where it's obviously much wetter, and you know, you would as engineers look at that and look at those irradiance levels. But with the cost of deployment having plummeted quite substantially since 2012, there's still huge opportunities. Now, if we look at deployment, you would say, if you go back to the previous slide, why is it so low? If I was an investor in solar or want to look at large roof mount, I would automatically go to the South England. You would, and then as that went, because ultimately that's where the best payback would be. But I thought it's important to show you that there is large parts of Scotland that are equal to other parts of the UK. What do we have in Scotland in terms of regulatory barriers, business rates? As it stands just now, and this is something that maybe discussing with clients, or when you're looking at systems, business rates can be an issue. I think this will be removed within the next 3 years. But right now, if you have two buildings side by side who command the same rates and who pay the same rates and that pay the same rent and should pay the same rates, one that is more energy efficient than another pays more tax because it has solar installed, because the solar array as part of that building can be classed as plant and machinery. That's an issue, and that goes against, fundamentally, it goes against Scotland energy policy. So that that should be the other way about, in my view. So that's something that has been looked at the minute. I do believe that's almost a kind of one of those things that's happened, and there's a rates review just now, and it's taken a bit of time. But that is an issue that the industry has. If we look at permitted development rights, permitted development was granted for solar up to 50 kilowatt, and this came from part of the kind of MCS micro renewables type thing, where I think heat was for the RHI was at 45 kilowatt, and solar was at 50. But Scotland has not been able to move that forward. England moved it forward around 3 years ago to 1 megawatt 4 years ago. But right now you need to apply for planning permission for a 60 kilowatt array, whereas in England you can put in a 900 kilowatt array and you don't need to look at planning permission. I would say, why is that? What would be the difference? And I would have thought it would be easier in Scotland to install solar, but as I've just shown you there, between that and the business rates, it is more challenging. Building regulations. I think this is something that I'm sure you'll all be aware of just now. As I mentioned, the next consultation. There is a danger, a real danger here, that in domestic and non-domestic, if you look at the notional buildings, that if you install an air source or a ground source heat pump, you no longer need solar. Now, or battery or what have you. And the issue that I have is that what kind of buildings are we leaving our clients to run and to pay for? And if we talk about fuel poor, if we talk about the type of buildings we're doing, in my view, what will happen is we will hand over buildings with higher energy costs, and certainly when it comes to running the heating system within that. And at some point, not long after the building is handed over, they will install solar and batteries to try and help them out. And I, as engineers, I'm thinking of that what, firstly, is that correct? If you are building a new building, clearly the most cost-effective time to install solar is when the access scaffold, etc., is all up there. The infrastructure's there, everything's very easy, not a year, 2 years, 3 years after. So I think there's a real issue here, and there is a consultation out just now, so I'm not sure when it's finishing. I thought it may have been the 5th or the last call for questions, or there was a last webinar on today, actually, I think. But I think it's important that as an industry that we give our feedback into that. I think consultations are really important, not just for building regs, for grid, for everything else that's out. There are so many though, and it is extremely challenging to be involved in them all, but I would certainly encourage people to try and take time out to answer these questions, because I genuinely believe the next round of the building regulations is going to put us somewhere where we don't want to be, certainly when it comes to just transition, fuel poor, and general energy consumption or cost of electricity within buildings. I think and I think this goes back to this ticking a box that I kind of mentioned here as well, and it's difficult, and it's difficult for you as well. And the way the construction industries, somebody said to me the other day, the construction industry is a race to the bottom, but the way it's set up, it's not set up for people to take licence of running cost as such. There is, we're trying to make everything more efficient, but it is, what is the cheapest way to build this building based on these minimum regulations, unless we go to things like BREEAM, etc., and then we all know passive house and all that, then we all know that they kind of look at it differently. And there may be, I hope that there may be things within planning, etc., which will help us deploy more things like solar and battery, and the local authorities want to push that, but that will need to be localised rather than from a building regs perspective, or how the construction industry set up. So that ticking a box is an issue. And again, let's look at the grid in terms of the infrastructure. When you're doing your application for new buildings and your new substation, what have you, if you're then saying, well, now I don't need solar, you're taking it out, it could be 2 years down the line when a client then wants to go ahead with that they can't, because the infrastructure is not there for it, which then puts them in another position. So there's kind of loads of things there that we kind of need to think about and look at that perhaps that we're not at the minute. I thought this would be good. I took this morning. This is the grid as it stands today. So, and I think this goes back to a lot of things that I hear from Scottish Government around a big appetite for EV and for heat, and as there should be. I generally believe they believe the grid is decarbonised and the job's already done, and I think that's part of the issue, because I think that when it's windy, it's not sunny, and I think there's so much opportunity if we can attach wind to solar to battery. That takes away that intermittency problem that everyone's worried about. So if we look at the grid carbon intensity at 11 o'clock this morning, we're at 171 grams of CO2 per kilowatt hour, which is excellent. You can see that gas is still the main driver of supplying energy at the UK though, and you can see that wind is doing really well. And again, it's a bit of a dreich day. I don't know what it's like down south, but it certainly wasn't great up here. And solar's doing 3 gig at the minute, which is obviously not very much. Number in interconnectors to Europe, a wee bit of hydro and storage. But if we look through the other side, there's a wee bit of 34 megawatts of coal we were operating this morning, a couple of interconnectors to Ireland as well. So I certainly don't think the job's done, in my view, and we want to try and get that down as much as we possibly can. So what opportunities do we have at the minute? The cost of solar has certainly dropped dramatically. So if you're speaking to the clients, it's really important to try and get up-to-date figures. I will say, apart from just where we are today, the long-term trend has certainly been to reduce, but I think we all know that where global procurement is in terms of cost of steel and availability after COVID, etc. So there's probably a wee period just now, which I expect in Q1, Q2 of next year, for the cost of the kit to maybe start coming down again. I mentioned before, new build construction is the most effective, the most cost-effective time that you can install solar anywhere. So if we don't think about that and think about running costs and think about the payback and think about the opportunities, or at least advise clients, I genuinely believe within a few years they will install it anyway, because the payback will be so low. So there's perhaps an opportunity to be missed. The synergy clearly is there, particularly as we look to decarbonise heat and use many more heat pumps, and as people decarbonise their fleet. I think behaviour and businesses and how they operate will change when we look at, or we speak to clients, they want to do loads and loads of things to decarbonise, and that's great. But what we always say, let's do something pretty straightforward first. And that could be put in EV chargers in a solar array, and then let's monitor your behaviour for 12 months. And then if you want to put a heat pump in, let's look at that. Then if you want to add battery storage, let's look at that. So I think it really depends on the client and what's going to happen, because what their electricity consumption looks like today will be completely different in 5 years. And certainly as we approach 2045 and net zero, it will be completely different again. And the buildings that you're looking at today, obviously, we're only talking 24 years from now till that will be net zero. So how do we make sure they're future-proof? What are we thinking about what we're designing and how we're involved within that, and trying to look ahead as best we can? I think one of the best opportunities, or one of the best sells, I suppose, of solar is that right now you're procuring electricity today for 25 years worth of electricity of your array at today's prices, and that could be 8-9 pence, whereas I've just seen a revised in my own home actually up to 24 pence per kilowatt hour, and that's only 2021, and that's only with the price cap just lifted by Ofgem. So where will that go, and where will that be in 10 years? I think it will be vastly different and massively increased. There's also loads of opportunities in terms of, because the grid is not set up to take embedded generation. So if you're speaking to your clients, there could be opportunities depending on the type of building, size of building, to be involved in local balancing networks. The DNOs, Scottish Power SSE it is up here, are really starting to look at flexibility and how buildings with big consumption can look at helping their grid balance in certain areas. We're involved in a pilot scheme for Aberdeenshire Council where we're looking at 500 social housing where the grid could not take solar or batteries as it stood. Now what we've done is there's been an aggregator involved, so he will get these 500 individual batteries, and there'll be some fast frequency response such that if the grid needs demand or a supply change in demand or a frequency shift, they will call on these batteries, which will help balance the network in that area. Now, 5 years ago, that would never have got ahead. It's a Scottish innovation project. It's been extremely challenging, particularly under COVID, etc. But that is where the industry, certainly when it comes to the grid. So what we want to see is the grid working with us, and not, technology or certainly solar and battery not being seen as a barrier or something that is given, the grid more to deal with. We see that as helping the grid, and I can see these funding mechanisms changed as well. Obviously, business profile, everyone's looking to decarbonise, looking to market how they're doing that. And I think it's one of the things that perhaps that you guys aren't aware of is that there's completely fully funded opportunities here. There is third-party organisations that will pay for the solar installation, that will pay for all of it and sell the energy back to the client and sell it for substantially less than what they're looking at and just in their usual buying it from the grid. So if you have a private network or a private wire that you can connect into your own building, then there's a huge opportunity there. So these are things that that perhaps you didn't know about before that hopefully can help you. I looked at kind of where consumption would be, the type of systems that perhaps we're looking at. One of the things that I've been getting our engineers to look at just now, and if you guys are certainly looking at it, looking at the roof, looking at the building type, looking if it's a completely south-facing roof, looking if it's east-west. I'm pushing my engineers now to go along the east-west route to spread that load. If we look at that graph at the bottom there, if you look at the middle part, which is south-facing, depending on what your consumption is of the building, you could be exporting a lot of that back to the grid. And if you export back to that grid, your client may only be getting 4 or 5 pence. Whereas if you can install an east-west, what you do is you take that tip off, you widen it all out, and it can fall within your self-consumption much better. So in terms of a payback, it could be much better for your client. Again, that depends on what, when they use it, what they use it. The graph at the top, or the image at the top, sorry, that's more a kind of domestic property. So I would see this in my own, that, this substantial at 9 o'clock in the morning. This could all be different, by the way, if, a lot of you will still be working from home, etc. So this could be substantially different because obviously you're in-house, heating's on, depending on if it's going to be from fossil fuel or not. But a lot of my graph at home would be that top image, where I would be generating during the day, not using, and then at night time start using, which doesn't help me. So again, as battery storage becomes better, perhaps we get vehicle to grid from an EV in the not too distant future, depending on degradation, then we'll look at changing that as well. So I'll quickly run through these. So some of the funding opportunities are here. Obviously self-funded, so within your own construction industry type contract, that would be standard. There is power purchase agreements, so that would mean that you could build that asset at no upfront cost to yourself. Someone like, we're doing a number of PPA offerings just now with E.ON. So a lot of these companies see that their traditional business model is different and they want to own these solar assets or renewable assets. So we are doing a number of PPA offerings just now. We're developing through that project. We haven't built any out yet. Where the funder, so the funder will pay to install, maintain it for your client and go into a contract to sell it. Now, there could be contracts, again, we just agreed one at 9 pence. Which is a PPA, and I think they're buying off the grid at 17 now. So that's quite a substantial change, and again, that's at no upfront cost to the client. There is also a really good offering at the minute from some inverter manufacturers and some solar manufacturers as well. So the one that we've partnered up was a Fronius lease offering, similar to a PBA, but it's a lease. So they will essentially lease the kit to the client, and at the end of the 15-year term, then you can purchase it for I think it's a nominal fee of £100 or something like that, and then hopefully get another 10-year life on that asset. So the numbers for that seem to work really well as well. Again, a lot of these are kind of new and innovative, and manufacturers within the industry are looking for opportunities to deliver their systems. And a lot of these people, cash is quite cheap just now, and there's not really doing very much in terms of from investments and stuff like that. So a lot of these massive companies are looking at innovative ways to try and get this deployment out there. So again, if value engineering, one of the things that we see a lot, and I'm sure you guys do as well, I've just seen one the other day, is value engineering, let's take the solar out. And again, how much value is that for the client really? So again, there's potential other opportunities to look at that point. So I wanted to give you an idea. Again, I talk a wee bit and have done always about ticking a box, and I was actually quite curious. I'm kind of not involved in so much of the seeing the day-to-day tendering that comes in. I took out all the names here, so if you recognise this building, then I would ask you just to keep that to yourself at the minute. So I've taken it all. So this is a building we've received in just now. As you can see, a substantial, beautiful building that could fit many solar panels on it and reduce the consumption for the client dramatically. But again, and again, this is part of, I suppose, as M&E engineers or consultant engineers, that's part of what you've been asked to do, is to get this building through building regulations. But I would ask you, to question yourself, perhaps is that perhaps the best way to do it? So I've tangled myself in my watch here. So again, this is happening today. It was happening 5-10 years ago, and it's still happening today. And so certainly it looks like as this continues in the next round of building regulations, we won't have anything there. And again, there's another example of what we've got at the bottom. So I thought it useful to give you a wee idea of what a typical solar PV proposal by someone like us would look like, and this is maybe something that you may want to look at, take on board and say maybe there's bits that you could offer your clients, and there may be other opportunities from a business perspective that you could also look at. So this is a fairly substantial system, 858 kilowatts. Sorry, I'm just going to try and move this up because I can't read this. 858 kilowatt peak system, 2,300 modules over 8 inverters. And again, probably the most cost-effective way to install is on a metal sheet roof, typical trapezoidal. I think that's one of the other barriers that I didn't mention a wee minute ago. I think it's when we're designing buildings, and I mean probably we're a very early conceptual design team, architect side, maybe before it gets to M&E consultant type side, but when we're designing buildings, what are we thinking of? Are we thinking of how can we make this most efficient? How can we get this in? We are, but in terms of the building regulations, I suppose, but many installations we see with extremely costly type roofs, maybe PVC Sarner type, what have you, with specific bracketry and fixings required that would cost the client quite a lot, and then we would fit solar panels on top of it. So it would be the most, and perhaps if it was a flat roof with a membrane, you would need some additional structural support in that. So if you look at that all together, it's a roof we're going to cover anyway. If we do cover it as best we can, we're going to get the running costs down, and we're going to get the roof type down, installation cost, the roof makeup cost of its entirety, including the installation, and the structural cost down. So there's potential massive savings that you can make rather than perhaps just value engineering the solar out. So I think though that would involve an even bigger change, I suppose, because that gets even before it's at engineer level, really at the very beginning of conceptual designs. So maybe we will see more of that, but this is typically what something like Emtec would look at now. There we go. So, and again, we would give them an example of how much they would generate, what would be their on-site consumption, what they would export potentially to the grid. So you can see the massive difference between export and generation. You might ask, why have any export? And I'm afraid it's just the way that solar kind of works. If we look at in the summer months, as you know, they can be quite long, 2, 3 in the morning, 4 in the morning, some places in Scotland. So you're generally going to export at that time unless you have a 24/7 building, which many of your clients won't. So there's always a wee bit, and you would never design it really for zero export because that would never be your best payback period. So we would always design it for some export. On top of that, if you look at that size of system, that's only meeting the client's electricity demand of 25%. which again, you might think that's only a quarter, but yet we're still exporting. That's just the way solar it works. But again, if you look at battery, if you look at connecting systems like that up, there's potential other funding mechanisms with balancing networks, etc., that I spoke to you about. So there's other opportunities. And again, as I said, I think for clients, this is the first step on many other steps towards decarbonisation. I think this is powerful. We only started doing this analysis in the last year, and the first time I seen that, my jaw hit the floor, to be quite honest. I looked at that tiny wee red bit of initial investment, and I looked at that massive bit of green, which is payback. And we looked at, if we look at this installation cost, which is 540k roughly, but a 25-year gross benefit are over £4 million, and a payback analysis 4.5. And again, that's based on 16.9 pence. That is not, the 23 pence that we're seeing just now. That is not, I mean, we would have an RPI of 5% on that electricity, I would have thought. So that payback could come down to 3 years easily, I think, just even with the kind of recent trends we've seen in electricity markets. So this is the type of kind of payback that maybe, and again, if you're looking at it for your clients, it might be something that clients would want to see, such that they get a wee bit of a better understanding. And again, we would show up a lease proposal or the different PPA or mechanisms or what have you that clients could potentially look at. And again, this goes through the PPA proposal. I thought I'd just give you a couple of quick case studies. Here's a ground mount that was done at a prison. Scottish Prison Service have moved forward quite substantially in what they're trying to deploy to mount it. So obviously we've got ground mount. Most of the stuff you would probably look at would be roof mount. But I do perhaps see your business model changing maybe over the next few years and more feasibility studies for just decarbonisation on retrofit applications, which would involve stuff like this. Rather than going out to contractors such as myself. We get asked to do designs for things like this all the time, but we can't unless there's a contract in it, because we're not a design engineering practice. We do have it, we are a turnkey practice, but we don't just want to do design and then put it to go in the open market. And that's the issue with a lot of the clients who deal with local authorities, etc., because of public procurement. They don't know what the asset they have at the start. They don't know what they can do as a design until they get it further down the line. So we'll see many more of these, many more of decarbonisation of schools, public authorities, assets, and I can see you guys get involved more than that. And again, patrol we're doing, here's a kind of typical installation we've recently done for Shell, believe it or not, on a petrol station, where we put battery storage, some EVs, a wee solar canopy and some roof mounted solar. We've actually just done the first non-petroleum site for Shell at Shell Fulham, which is just EVs. So you're going to see, and again, you may, if you're here at the ground, there's companies like GridServe that have bought the Ecotricity, the electric highway framework or network, sorry, up the motorway, so from England right up. So I think it goes as far as, certainly comes into Scotland and further. So they have procured that business recently, and they have a massive rollout of EV only charging hubs. So what opportunities do I think are there for CIBSE members? The first thing I would say is maybe not ticking a box, maybe looking at different aspects of it. There might be better opportunities for better fees. Speak to clients and speak to them about life cycle savings. I think clients' behaviours will change from the building that you hand over at practical completion till it will be in 5-10 years' time. And I think that there's ultimately, as I said, on that journey, they will at some point have solar on that roof and battery. And EVs and all the rest of it that goes with it. So it's potentially the best to do it when you're actually constructing the building. There might be opportunities that I can certainly see when it comes to your existing client database and looking at buildings that you've done previously and seeing what are opportunities there for feasibility studies, for fees, for speaking to clients and say, how could we look through what you'd be designed back then, how your behaviour has changed and what you could do now. And I think one of the biggest things I would honestly ask, if I can get one thing across today, would be try your best to look at consultation responses, because they do actually listen. And when we look at Scottish Government consult, there is huge opportunity just now, and they are asking for industry experts on, what do we need to do, what can we do. Certainly with the grid, the next price control is ED2, which is starting on 2023 to 2028. So the DNOs just now are asking for money for for certain things that they can do to allow for this transition towards net zero, and make sure the infrastructure is there for the buildings that we want to build towards that. So they are asking for lots of consultations, and I don't see the construction industry involved in them very, very rarely. One or two people might be on this that I've been speaking, but I am really active in the grid. I believe it's the biggest barrier to deployment, and it's the biggest cost that our clients will see when they try and connect and decarbonise. So massive opportunity there, including Ofgem. Again, Ofgem, I think sometimes it's Ofgem we need to lobby against rather than the DNOs, because the DNOs do have their hands tied to a certain extent when it comes to Ofgem. So again, any consultations for that, and again, speak to the trade bodies that are out there, whichever interests you. Certainly the work I do with Solar Energy Scotland and Solar Energy UK is quite substantial, and there's some good stuff there that I certainly think that you guys could certainly feed into or be part of and learn so much more. So there's a lot of opportunity that way. That would be me. So thank you everyone for listening. I think I don't know if England's going to do any questions at the end, if there is any, but thanks for your time today.
Thank you, Chris. That, I think, gives us all a lot to think about, and maybe a lot to act on as we go forward. Ingrid, can you see any questions coming up?
Yes, so if people could put in questions into the chat, I could read them out. I think at the moment there's only one. I think, yeah, it's not so much a question, more a statement. One thing I was going to ask, I don't know if you've looked into the embodied carbon on solar panels. We get asked that a bit about what's not just the monetary payback, but in terms of the carbon payback. I don't know if you want to.
I don't know. I don't.
Questions come up.
I've not been asked. I think that's been mentioned once, but I mean, I should really know, shouldn't I? I certainly, as the industry, should know. I would think that some of my colleagues at Solar Energy UK would possibly know that. So I'm going to take a wee action there, Ingrid, to actually come back with something like that.
That's sometimes something that puts people off putting PV on at the moment for us anyway. So Scott is asking, when the grid hits. All right, that's kind of similar to what I was just saying. When the grid hits zero, what is the argument that we can make to install solar panels, given that they'll be offsetting no carbon?
So I think ultimately, see by 2070, which I'll probably not be alive at that point, but by something like that, will we even need a transmission network? So we talk about the grid and the way it's connected, but will we need a transmission network? Will we be able to self-generate? I can certainly see all these wee EV cars, mini substations driving around, plugging into car parks, running city centres. So we will all be self-sustained, solar, motorways and solar on your roof, and there'll be this whole all things being interconnected. So I think, and ultimately, I think part of the issue that I see just now is that Scottish Government believe that the grid is so far decarbonised that the job is almost done. But for me, again, for clients as well, it's about cost of electricity and cost to run. So it is about decarbonising, absolutely, but it's also about cost to run. I think there will be a really big clampdown on, when you look at these electricity retail companies. Obviously, there's quite a few less now than there was last week, and I dare say there'll be substantially more or less over the coming months. But this, we will sell you 100% renewable energy all the time. I think that needs clamped down on. I don't think that's regulated as much as it could be. So, and again, so yes, when the network gets to where it needs to be, but it's got a while to go, I think. I mean, we're showing, look how far we moved in 2021, and we've got 34 megawatts of coal in October. So what will that be like in December? So I think we've a while to go.
Oh, there's another one. Oh, there's a few covered through now. Any thoughts on integrated PV and roof? That's something.
Yep. So integrated. So when we say integrated, so there's two. There is integrated panels out there, which is that kind of fit in like a Velux window, if you like. But then there's BIPV, which is the traditional integrated, which is essentially, you know, it could be form part of kind of glass, which it actually forms part of the roof rather than a panel. Now, they look beautiful. And I have been involved back in the day in many an initial design for them, which has unfortunately been value engineered out. So I think for what happens when you do BIPV, they become twice as expensive and half as efficient. So it's a factor of 4 really compared to a traditional solar module. So obviously solar modules are mass produced. They're getting quite good at it. But when you do BIPV, it is a different animal. Now we are doing BIPV at that Shell Fulham site I told you about, because it is a real cool but it is a pilot but it's pretty expensive as well, to be quite honest. So it really depends, and if you know, depending architecturally what people want to look at. But right now, you just need to be aware that it's half as efficient and twice as expensive for the same square meterage.
Someone was also asking about the same point there. Is it an issue that the roofs have a longer lifespan than the PV panels if you're integrating?
I don't actually know, because to be honest, I've not done that many integrated. But you know, I would say no. That the whole part, I would say no. I think that the technology will certainly move forward. Will we see a change? So you would think, you know, I suppose how long it will last, but then it depends what type of roof. How long has a roof got just now? I don't know if there's any architects on here. 25 years, something like that. I would say that maybe that's as long as the solar array. So I think you may or may not be okay with that. I'm not sure.
Someone was asking in terms of solar shading from adjacent developments, would you recommend avoiding shaded roof sections completely, or would you design the PV system such that generation can still be reached at part shading? So
what I would wet shading's a good one. Something I probably should have spoke about a wee bit, to be honest. So there's two different types there's traditional string inverter type systems, and then there's optimized systems. There's a manufacturer out there called SolarEdge that we use quite a bit. Again, but this goes back to, you know, if it's not within the specification, then it's a wee bit more expensive, so a contractor's not going to put it in. So you don't get the chance to use it as much as you would like. But if you have an optimized, so if you have a traditional string inverter, if you connect 20 panels up in the one in series in a string, if one panel is in full shading, it doesn't just affect that panel, it affects the full string. So it's really important that when you're designing that you're looking at that. And again, if you look at each panel, there's usually 3 sections in it. And again, depending on how the bus bars are arranged, it can, if you install it landscape or portrait, it can affect the panels differently as well. So you kind of need to be careful. If you have, I would always install in shaded parts up to 10% shading. And again, if you modelled that, you'd be able to see. But if there is some shading in it, I would seriously look at an optimized solution, and you'll find the yield you will get will be still really, really good, because it's optimized. Say it's one optimizer per 2 panels, it'll only be the 2 panels that will be affected, rather than the whole 20 if it was a traditional string inverter. So it's kind of ways to look at designing it if you've got city centre buildings or what have you with some shading issues.
Maybe a quick one. What is the highest percentage efficiency of PV panel up to at the moment?
Don't know off the top of my head, but it would be the SunPower 450 watt. But I don't. It's funny because and this comes from the model. So we look at kilowatt peak output. So we would model various things and look at the size of roof, try and get the best fit, get the best yield, and look at it that way. It's only the M&E construction industry that looks at square meterage, and that stems from IES or what have you. So they look at square meterage and they want to put a minimum percentage in. Now for me, you know, I would look at the building and I would look at the building roof in its entirety and look at what I could get would be the best solution overall, because for example, that SunPower 450, 500 watt module, whatever it may be, it might have a much better efficiency, but you might have loads of space anyway. So your client would not get the best bang for buck there, you know, and not, you know, everybody wants to drive a Ferrari, but sometimes it needs to be a Volkswagen Passat. So we need, it depends what the best solution is, and what it's ultimately about the yield at the end. For me, it's always about the yield at the end and what can we get to fit. But it's probably one of my engineers would be able to tell me, to be honest, but unfortunately I couldn't tell you up to date. It's changing that often.
I have time for maybe one last question. Well, there's a few people covered in now. Do a lot of the projects you have worked on export energy back to the grid? We've found this is often tricky on medium-sized projects due to grid restrictions.
Aye, again, you can there is ways around that with export limitation devices, etc. But that's why this is you know, you're playing with two things here, because you're trying to design it to get it through building regulations. So depending on how much solar you need or want, but you're also want to look at energy consumption in the building. So see, right now, we would just always look at half-hourly data for existing clients, always first. But the day of looking at the size of a roof and flooding as much as we can is over. So we would look at behaviour. And again, I think when we look at export back to the grid, the behaviour of your clients will change once, depending on the type of building, and once they introduce EVs to the fleet, etc. Then that will all change. And I even look at working from home just now and all that sort of stuff. So it's moving all the time. So it's difficult to assess what's right at the very start without future proofing and thinking ahead. So again, I would try, and if you're looking at buildings to design, I would always try and design on what you think the building usage is today and what you think it might be in 5-10 years, to be honest. And then if there could be, you know, if you fit grid export limitation because you have to just now, don't be scared to still oversize that solar array, because you'll lose a wee bit. But see, in 3 years, you might want to take that grid export limitation off because you've found that your consumption is much higher, or that it's not been utilised anywhere near as much as you thought. So again, maybe a wee bit about future proofing.
That's great. But Jeremy, do you want to say anything else, or probably all we've got time for in terms of questions? Thanks very much, Chris.
Yeah, we'll take one more question.
One more? Time for one more. Let's see. Given the variance in the radiation across the UK, what constitutes 10% shade with regard to the requirement for solar edge optimizers?
You would need to model it. So we would model it. When I say we, I mean the royal we is, but you would need to model it. So every building would be different. Again, that's some of the issue you guys have, because I don't know what kind of PV-SOL type or PV-SYS type modelling software you have, but every building we would model. As we model that, we would look at each panel, we would look at the impact of shading on each panel, and then we would adjust all the arrays to suit. It's difficult for you, as I get it. I don't know how you'd be able to do that from a kind of general, so it might be to speak to the partners and board levels to get some modelling software in for that kind of thing, each of the practices.
Great.
Okay.
Thanks, Chris.
Again, thanks very much, Chris. I think that was a really good talk. And maybe we'll ask you again in a not too distant future, and see which way it's all going. So to those of you listening, I hope you enjoyed the talk, and we are planning now a series of talks on various topics going forward. We've got a couple of talks coming up, in fact. If you go to the CIBSE website, I think you'll find the details there as they become available. Ella, maybe you could just tell people where to look. I don't know if
I'll post the link on the chat for now.
Right. I don't know if there's somebody that can actually sign in so that they get the emails that go out to the members. But anyway, if you're not a member, of course. If you are a member, you should be getting the invitation emails, and if you're not, you should maybe check your account settings, because sometimes they get switched off. Okay, well, thank you everybody for attending, and I look forward to seeing you all, or you seeing us, I guess, at the next seminar. And thank you again, Chris, and Ingrid, of course, who did such a good job
reading out the questions.
Reading out the questions.
Thanks for all your questions.
And Ella, who's you won't have seen, but she's in the background, keeping us all.
Thank you.
Keeping us all in control. Okay, thank you, everyone.
Thanks.